Hi everyone, it's me again, Mr. Cox. So today I'm going to go through how to do each one of the 5 different types of molarity problems, or basically the 5 different ones that I've given you today. And they're actually not that difficult, so feel free to jump ahead or see which one maybe you got stuck on one. Alright, so if you look up here at the top, there are 3 different formulas that they will give you. So molarity, which is a capital M, is equal to moles of solute divided by liters of solution. So we talked in the last video about how molarity is just a measure of concentration, and you do moles divided by liters. Alright, so if we want to find moles, all I've done is I've just rearranged this formula and gotten liters times molarity. And if I want to get liters, I'm just going to do moles divided by molarity. Alright, so at first it wants you to find the following terms. Alright, so concentration is the amount of solute per solvent. Alright, so that's pretty easy. Alright, dilute is going to be not a lot of solute per solvent. Concentrated, on the other hand, is the opposite of dilute. So it's going to be a lot of solute per little solvent. And I know you may be thinking, what in the world? What are these words he's using? Solute is the powder that gets dissolved. Solvent is the liquid that does the dissolving, and most of the time the solvent is going to be water. Alright, molarity is going to be a concentration unit. Moles over liters. Okay, so now for number 1, it says calculate the molarity of a solution if there are 1.5 moles of NaCl in 2.3 liters of solution. Alright, so it says 1.50 moles, MOL, that's the abbreviation for moles. So the moles is going to be 1.5. And this is just MOL. Alright, in 2.3 capital L of solution. So the capital L here stands for liters, so I'm going to put 2.3 capital L there. Alright, so the molarity is the question mark. It's the unknown. It's what we don't know. Alright, so if you look up here at the top, if we need molarity, we can use this first formula where we do moles of solute, moles divided by liters. Alright, so I'm going to abbreviate molarity as a capital M like this. Alright, so capital M is going to be equal to 1.5 moles, so 1.5 moles over 2.3 liters. Okay, so now I'm going to take out my calculator. And let's go over here, turn it on. Alright, so we've got 1.5 divided by 2.3. And that gives me 0.652173. And I'm just going to round it to 2 decimals. And it's going to be 0.65. And if you want to, you can either put a capital M or you can say 0.65 molar. For some reason, when they were doing abbreviations, molar is an abbreviation for molarity. I know, it's very odd. You could have also just put a capital M like that for molarity or molar. Alright, so let's go on to the next one. It says, how many moles of sucrose, and it gives you the chemical formula for sucrose, would be in an 8.7 liter, would be in 8.7 liters of a 1.1 capital M solution of sucrose. Alright, so 8.7 with a capital L here. The capital L stands for liters. So let's do 8.7 liters here. Okay? Alright, and then we've got 1.1 with a capital M. And watch out, the capital M actually stands for molarity. It's not moles, it's molarity. So 1.1 molar, or molarity, is going to go here. And now moles is going to be our X, our unknown. So if you go back to the first page or you scroll up, we have molarity and we've got liters. So we need moles, right? So if moles is the unknown, we're going to use this second formula here. Moles is going to be equal to liters times molarity. All right, so moles is going to be equal to liters times molarity. All right, so moles equals the liters, which is 8.7, times 1.1. All right, so moles equals, and let's get out my calculator here. All right, 8.7 times 1.1. All right, 9.57. All right, so the answer is 9.57 moles. All right, so it says how many moles of sucrose. So we gave them what they wanted, right? We gave them moles. So X is going to be equal to 9.57 moles. And there you go. That's it for that one. All right, next one. It says how many liters of a 0.225 molar solution of Ki, which stands for potassium iodide, are needed to contain 0.935 moles of Ki, which is potassium iodide. And for some reason this is worded really weirdly, but it's the same process. Okay, so we've got 0.225 with a capital M. All right, so 0.225 with a capital M, all right, this capital M means that it's molarity. So this 0.225 is going to go here. All right, and then the next piece of information, the next number that they give us is 0.935 moles. So I'm going to put 0.935 moles there. And now the liters is X. We don't know what the liters is. So if you look back onto the first page, or if you scroll up on your page, you can see liters, if we need liters, which we do, right? Liters is our X. Liters is going to be equal to moles divided by molarity. So let's write that formula here. So liters equals moles divided by molarity. All right, so now let's plug in our information. So liters is what we don't know and what we're trying to get to. We're going to do the moles, which is 0.935, so 0.935 over the molarity, which is 0.225. All right, so now take out my calculator. I'm going to do 0.935 divided by 0.225. All right, and that gives me 4.15 repeating. So I'm just going to round this to 4.16. And now what we were looking for was liters, so I'm going to put a capital L, or you can put liters. You can spell out the word liters just like that. So X is going to be equal to 4.16 liters, written out just like that, or capital L. You can do either way, it doesn't matter. All right, so it says how many grams of CaF2 are present in 1.25 liters of a 0.15 molar solution of CaF2. The molar mass is 78.07 grams per mole. Okay, so this one is a tough one. And let me walk you through how to do it. Okay, so this 1.25 liters, or capital L, is going to be the liter. So 1.25 capital L, or liters, is going to go here. This capital M here, the 0.15 capital M, that is going to be a concentration. It's going to be a molarity because it has the capital M. Okay? So this is going to be 0.15 with a capital M, meaning it's molarity. All right, so now what we don't know is we don't know the moles. This is an X. And it wants grams. So here's what I suggest we do. I suggest we get the number of moles from doing one of the formulas, and then we can convert the moles into grams by multiplying by the molar mass. I know it's a lot. All right, so let's look back here at these formulas. All right, we have molarity and liters, and we want to get moles. So looking at these three formulas, we want to use this one. We want to use the one where it says moles equals liters times molarity. So let's go moles equals liters times molarity. All right, so moles is going to be equal to, all right, liters, which is 1.25, times the molarity, which is 0.15. All right, so now we can take out our handy-dandy calculators. All right, I'm going to plug in 1.25 times 0.15, and I got 0.1875. So if you can't see that there, 0.1875. I'm going to round mine to 0.19. All right, so 0.19, and that's in moles. Okay, so now we need to convert these moles into grams. How did I know that I needed to do that? Because it's asking for grams. It says how many grams. It doesn't say how many moles, but we had to get the moles first so that we can get to grams. I know it's tedious and annoying. Okay, so to get from moles to grams, here's what I'm going to do. I'm going to set up 0.19 moles, like so. Draw the X and then draw the fraction bar like that. Remember the horizontal lines we've done. The word that I just put here has to go onto the bottom here. And the one that I'm trying to go to is going to go on the top of the fraction bar. All right, the one that I'm trying to go to is grams. All right, what number should always go with moles? Great job, it's a 1. All right, and now it wants some number to go in this grams box, and that's going to be the molar mass of this compound, this CaF2. But luckily, someone was nice enough to give us the molar mass here, and it's 78.07. So I'm going to put 78.07 here. All right, so now what I'm going to do is I'm going to take this 0.19, I'm going to multiply across the top, and I'm going to divide by the bottom. So it's going to be 0.19 times the 78.07 divided by 1, and that'll give us some number, and that is going to be in grams. That's going to be your final answer. All right, so now on my calculator, I'm going to do 0.19 times 78.07 divided by 1. All right, I have 14.83333. All right, so I'm going to round, and mine is going to be 14.83 grams, just like that. Okay, and this is actually your final answer because it asks for grams. It says, how many grams do I need? Or how many grams are present? So this is the final answer here because it's in grams. Whew, that one was a tough one. So if you want, hit pause. I'll still be here. You can, recover, or you can go back and watch a certain portion of the video if maybe you're behind. All right, now it says, what is the molarity? This is number 5 here, so I'm right here. What is the molarity of a solution that is made by adding 57.3 grams of MgO to 0.5 liters of solution? And it says the molar mass of MgO is 40.034. Okay, so what they want you to do is they want you to determine the molarity. They want you to determine molarity, so that's going to be X here. They gave you 57.3 G, and this G stands for grams. So that's neither moles nor liters. All right, and it says 0.50 capital L, which stands for liters, so that's 0.50 liters. All right, and it looks like we have 2 unknowns. Well, we really don't, because we have this other piece of information here. We've got the 57.3 grams, and we can just do the opposite of what we did here, and we can convert the grams into moles. All right, so what I'm going to do is I'm going to write out 57.3 grams, draw an X, and then draw a fraction bar like that. All right, the word that you just wrote goes down here on the bottom for grams, and the word that goes up here on top is what you're trying to go to, which is moles. All right, so let me take a step back and explain what I'm doing here. So they want to know what the concentration of, or the concentration of the solution is, and they want to know it in molarity. So I made that X. That's an unknown. That's what I don't know. But they just added 57.3 grams of MgO to 0.5 liters. So they're trying to discover what the molarity is, but they just added grams of this substance and then filled it up with 0.50 liters of water. So in order to get molarity, which is moles divided by liters, I have to convert these grams into moles. Okay, so 57.3 grams. A 1 is going to go with the moles because 1 always goes with moles. And then we're going to need the molar mass for this MgO. And the molar mass for the MgO is right here. Someone was nice enough to give it to us. It's 40.034. Alright, so now in my calculator, I'm going to do 57.3 times 1 divided by 40.034. Alright, and I got 1.431, and I'm going to round that and do 1.43 moles. Alright, so then this number, the 1.43 moles, can now go here. And now we have moles and liters. So, in order to get molarity, moles divided by liters will give you molarity. So now I'm just going to plug this in. So molarity equals 1.43 divided by 0.50. All right, and again, I'm going to use my calculator. I'm going to do 1.43 divided by 0.5. And that's going to give me 2.86, and it's a capital M, or you can put molar. All right, so now X over here, we can fill this into this chart, equals 2.86 molar, or a capital M like that. Okay, so that wasn't too bad, right? The last two were kind of difficult, but most of these were not that difficult. All right, so if you have questions, please send me an email or comment on Google Classroom. I hope you enjoyed this video. Have a great day.